there was life in these bits of rock. I think the internal evidence from the meteorite is so strong that I think this is perhaps the strongest evidence to date of life coming in from outside, even at the present time.
Professor Chandra Wickramasinghe studied at Trinity College in Cambridge, earning his Ph.D. in mathematics in 1963, and a doctorate of science 10 years later. Wickramasinghe has written over 40 books, published over 400 technical articles, and is currently an honorary professor at the University of Buckingham. Together with the late Sir Fred Hoyle, he's best known for popularizing the panspermia hypothesis.
My entire career has been an academic career at universities, starting from Cambridge and then moving to Cardiff. And I feel really greatly privileged to have had all of this time, several decades, working on perhaps the most interesting problem in the whole of science, namely, how did we come into being? How did life come into existence? That's what I really wanted to start. And this is a quest that started with my early years in Sri Lanka, when I first encountered books by Fred Hoyle and Arthur C. Clarke was a science fiction writer who lived in Sri Lanka, and I had many interactions with him. So it seemed more or less natural for me to go into astronomy when I got a scholarship to come to Cambridge. And also I should mention that there was a long family tradition of mathematics in our household, in my family. My father was at Cambridge himself, at the University of Cambridge in the 1920s and early 1930s, and he obtained the highest honors in mathematics at Cambridge University. He was a pupil of a guy called Sir Arthur Eddington, who essentially was one of the main promoters of the Big Bang theory of the universe. So this was the sort of backdrop that I grew up in as a young child and as a young adult. So it was more or less natural for me to drift into science and eventually into astronomy. I think panspermia is one of the options for how life began. Pans, it's an ancient Greek word. Pans means everywhere, spermata meaning seeds, and so panspermia meaning seeds everywhere. And this was an idea that was first discussed by the Greek philosopher Anaxagoras, and he lived in around the 5th century BC, 500 BC. He was almost contemporaneous with Socrates, and so he said that life is everywhere. Life just happens to take root whenever conditions become favorable. So that was the beginnings of panspermia in the Western context. However, in the ancient Indian context, in the Vedas, for instance, the concept of life everywhere is almost taken for granted. So life is universal. That's a Greek idea that came from Aristotle, but it has earlier priorities or connections with ancient India. The idea really stems from the fact that there was a time on the Earth close to 5 billion years ago, or 4.8 billion years ago, when the Earth was just forming out of really hot molten asteroids and sort of rocks, gigantic rocks colliding and going to form the Earth, primitive Earth. And so for a long time, the surface of the Earth would have been almost molten hot, and there was no chance of any life being on that surface. Then recently we have data that goes back to 4.2 billion years, which is 4,200 million years before the present. And the oldest rocks that formed at that time have unequivocal, unambiguous signs of microbial life. And these are now rock formations that were exposed in Australia, in southern Australia, and they have been studied, and the evidence for life being on the Earth at that time is absolutely beyond dispute. So life had a definite moment in time when it started. And by life I mean just microorganisms, simple bacteria and so on, appear to have been on the Earth as far back as 4.2 billion years ago. Now, from 4.2 billion years ago to about 3.5 billion years, there's been only evidence of microbial fossils, microbial life on the Earth. So a full 1.5 billion or nearly 1.25 billion years after the first life appears on the Earth, nothing further has happened in terms of evolution or development. It's all bacteria, right? And then what happens thereafter is an evolution of higher other life forms, of plants, animals, and so on, that happens sporadically throughout geological time from, say, around 3.5 billion years ago to the present. So that's the broad picture of how life originated on the Earth or started on the Earth, the first evidence for life on the Earth, and how life has been developing on the Earth. Well, I think it's exceedingly likely that life came from these external objects that were striking the Earth. Comets and meteorites have been hitting the Earth from the time that the Earth formed its original crust. And so that's been happening right through from 4.2 billion years ago to the present. And if you look at the meteorites that are falling today and have been recovered in the last 50 or 100 years ago, the evidence is really crushing for microbial fossils being inside those meteorites. But life in meteorites is absolutely clear-cut. We refer to the Thyssen meteorite, but my personal involvement has been with a meteorite that fell in my native country, Sri Lanka, in the year 2013. And the story is that one autumn night, a sort of poor subsistence farmer who had few acres of rice paddy field went out to I think water his newly planted rice crop, and then he looked up at the sky and he found a huge lot of sort of gigantic fireflies. He described it as a shower of fireflies falling from the skies. And the guy was so frightened that he rushed into his house and shut his windows and so on, and didn't come out till the following morning. And when he did come out to look at his rice and his paddy fields and so on, he found the whole field splattered with little bits of meteorites. And so fortunately, we had some colleagues and friends who were able to collect this stuff, send it to the Medical Research Center in Sri Lanka. They thought that this was a health hazard, and so they sent it to the Medical Research Center. And from them we got samples. We sent samples to various places in the United States and so on. And this has been a subject of intense study for about 3 years, from 2013 to 2016. And a guy called Jamie Wallis did his whole Ph.D. thesis, doctoral thesis on this, and on this meteorite, and concluded that there's absolutely no doubt that it was not they were not terrestrial rocks. There were signatures, which are signatures of isotopes, and isotopes are different forms of a chemical element, right? The oxygen isotope was what Jamie Wallis looked at. The common isotope that we breathe, the oxygen that we breathe, is mostly oxygen 16, right? Atomic weight 16. The oxygen in the rocks and in the plants, all oxygen has the same atomic weight, whereas in the Polonnaruwa meteorite, it was different. There was more oxygen 17, 18 than oxygen 16. So on that basis alone, we were able to conclude very strongly that this was an extraterrestrial meteorite. It came from space. And then when you looked at these under the microscope, under the electron microscope, there were diatoms, minute organisms that look like the organisms that we see in vast quantities on the surface of the Earth. So there was life in these bits of rock. But to this date, the American Meteoritic Society has not accepted the Polonnaruwa meteorite as a definite meteorite because there was no recorded evidence of a meteorite fall. And this the listeners should remember, viewers should remember, is a remote part of Sri Lanka where poor farmers did not in those days, in 2013, have smartphones or anything that could record these easily. So the fact that the recordings don't exist is not a proof of their non-existence. I think the internal evidence from the meteorite is so strong that I think this is perhaps the strongest evidence to date of life coming in from outside, even at the present time. The main problem that we face with this meteorite is that it has not yet been recorded in the Meteoritic Society annals or in the records as a meteorite, a witnessed meteorite fall. And the reason given is that there was no evidence of anything falling from the skies, no video recordings on smartphones or anything like that. But one has to remember that this is a very extremely remote part of Sri Lanka where the rice paddy fields were. The farmer was a poor subsistence farmer. He had no access at the time to anything like a smartphone. So the fact that there is no photographic or video evidence is totally irrelevant. And there were even more damning racist comments made of this meteorite. Someone on the internet said that in Sri Lanka the poor farmer wouldn't know the difference between cow shit and a meteorite, right? So we got to disregard this. And the fact is that the most powerful laboratories, geological laboratories, both in Sri Lanka and in Britain and elsewhere, have examined this, and it's certainly not cow dung. It is a rock imbued with elements, isotopes that are alien to the Earth, and imbued also with evidence of diatoms, microscopic life forms that are embedded within this meteorite. There's no chance that it is a piece of Earth rock or anything on the Earth. Yeah, we know that the diatoms in the meteorite are indigenous to the meteorite because they're essentially locked into the matrix of the rock. Right? These are just embedded in as part of the rock. And what is more important even than the diatoms is a structure that was discovered both in Cardiff and in the US by Mr. Hoover of something called an Acritarch, which is an extinct microorganism, extinct on the Earth for something like 3 billion years or so. And you got that inside the Polonnaruwa meteorite. So it's a bizarre situation where you're making the assertion that this cannot be this is an Earth rock, and you have stuff in it that cannot be anywhere near the Earth's surface at the present time. Maybe they're deeply buried or something, but the acritarchs have been out of the Earth's environment for something like 3.5 billion years. So that's another aspect that is really very interesting in this whole story. But the general position is that the stronger that the evidence becomes for extraterrestrial life and for panspermia, the stronger is the resistance, both institutional and societal. I think people are not used to the idea of admitting that we are not supreme, life on Earth is not supreme, and life on Earth is not essentially unique in the universe. So this is an obstacle that is largely a cultural obstacle, but one that is continually facing us at every turn. There's no question that culture plays a very, very important part in controlling the general public's attitudes and views on life in the universe. So it's harking back to the days of rejecting this old guy that we call Anaxagoras in the 5th century BC and taking on another philosopher who emerged in ancient Greece 200 years later, and that philosopher is called Aristotle. Aristotle proposed that life starts by a process of spontaneous generation, and he referred to instances, or also examples, graphic examples of fireflies emerging from a mixture of warm earth and morning dew, and he thought that this was clear proof of spontaneous generation of life on the earth. So that's one of the many examples. And then from 300 BC, this Aristotle guy, the philosopher Aristotle, is a very, very powerful character, as I told you. He was a tutor of Alexander the Great, amongst other accolades that he has, and he was essentially taken over by the Catholic Church as an official philosopher for the Church of Rome. And Aristotle's philosophy also included the concept of the Earth being at the center of the universe, certainly at the center of the solar system. Anybody who challenged that, who challenged the Aristotelian view, were persecuted. There's a guy called Giordano Bruno, a very famous poet, philosopher, who in 1500 was burnt at the stake by papal edict because he transgressed the papal authorities of saying that life is outside the Earth. He said that other planets exist. Other planets with life seems to be the most reasonable way to think of the universe. And then Galileo, who said that the Earth was not the center of the universe, was imprisoned and under house arrest. And so it went on, and right through until the Enlightenment, the ideas of Aristotle seemed to dominate all other competing ideas. And it's changed in the 20th century to some extent. People are more liberal, but I think the old Aristotelian viewpoint still lurks in the background. A diatom is a microscopic organism that has a siliceous outer shell. Silice is mainly made of SiO2, sort of structures of SiO2, polymers of SiO2. Sand is made of silica, one silicon atom and two oxygen atoms linked together. And the diatom contains this compound with silicon SiO2, one silicon linked to two oxygen atoms, producing a sort of a mesh around a structure that is normally like a bacterium. So around a bacterium, you have a very hard shell, which is made of essentially of glass, of a glass-like material. On the Earth, they are very common. They're extremely common. If you pick up a handful of soil, of sand on the beach, you'd get the large fraction would be diatoms. Oh, elsewhere in our solar system, certainly, and elsewhere in the universe as well, because one of the things that we found in the 1980s was evidence in very, very distant astronomical sources of both bacteria and diatoms. And this was a sort of mind-blowing discovery for most astronomers at the time, because we predicted that if there was bacteria, freeze-dried bacteria, dried-out bacteria everywhere in space, and that was the contention that we had at the time, that cosmic dust was basically bacteria plus diatoms plus maybe viruses, then one should be able to prove this from what is known as astronomical spectroscopy. You look at a distant astronomical source, a star or a nebula, and the light from that source crosses vast distances of dust, crosses the cosmic dust in between the source and ourselves on the Earth. And so you should get some kind of signature of the material that is at the far end. Just as if you look at a street light through a fog, you would see the evidence for the fog, right, in the light that you collect at the end of the on the Earth or at a great distance. In a similar way, we predicted that there should be evidence that we could find of bacteria and diatoms, and sure enough, when these astronomical observations were made in the early 1980s, the evidence was very, very strong. There was evidence for bacteria, there was evidence for diatoms. We published a whole lot of papers, and they have been in peer-reviewed journals in Nature and so on evidence for bacteria and microorganisms in space. And they've been published and they've been reviewed, and they've also been criticized for essentially challenging a long-established paradigm that there could not be life outside. I think life has a unique origin, not connected with any individual star, planet, star, galaxy even, but connected with the whole universe. The whole universe is involved in the first startup of life and in all of the information that is needed for the further evolution of life. And this is distributed in the form of viruses. Viruses are carriers of genes. We know that from studies of life on the Earth. So this is the picture that is now emerging. And I should perhaps mention that in the last 3 months, 4 months, there's been new discoveries made by the James Webb Telescope. And these discoveries have a really significant impact on all these questions. We are finding galaxies, which are collections of stars like our Milky Way system, at distances where there should be no galaxies, right? The idea that is generally considered the standard theory of cosmology of the universe is that the universe began with a Big Bang 13.8 billion years ago, okay? And now they're finding, James Webb Telescope are finding galaxies at 35 billion light years away. 35 billion. So there was no universe at the time, according to the standard Big Bang theories. So all of the conventional wisdom that we've lived with for several decades is being challenged very, very significantly at the present time. And so I think the universe had no beginning, perhaps had sort of an undulatory, oscillatory past. And life within it had no beginning. So that would be my conclusion that I would draw at the present time, tentatively, of course. And there's no evidence for life starting on a small scale in any individual group of planets or even in an individual galaxy like our Milky Way. A much, much bigger system was needed to generate what I would like to call the information needed for all life. Because life depends on information, right? And this is what is lacking in small systems. The Earth is just a trivial backwater in the cosmos. Nothing much could happen on the Earth. The Earth could take in all this stuff from the bigger universe, could amplify it, could take in the meteorites and show us that there are structures within the meteorite which are living structures or once living structures. But there's no evidence for a small-scale origin. So I think the game is up. We have evidence for life in the meteorites, evidence of fossil life in the meteorites. We have evidence for life as far as you can imagine in the galaxy and beyond. And so I think it's high time that we gave up the struggle to maintain the old Aristotelian position, the old Earth-centered position of life being centered on the Earth. They are scared to have Gil Levin's Viking experiment confirmed and vindicated on such a low budget. I think there's an issue of budgets here. I think if you say that the search for life is finished, then I think NASA and all these space agencies would lose their funding. Major component of funding for all of these space missions is the search for life, right? And recently the European JUICE mission, J-U-I-C-E mission, was launched only about a week ago to the moons of Jupiter to look for evidence of life. And evidence of life on the moons like Europa, for instance, that had evidence for maybe 20 years now of possible life underneath the crust of Europa. So they're sending these things, and it'll take 8 years for them to, for this mission to reach Jupiter and Jupiter's moons. In the meantime, also NASA is sending a competing mission. So there's a lot of funding going on to try to protract the process of looking for life outside of the Earth. And eventually, I think the evidence is really crushing at the moment, but admitting it would mean that that's the end of the game. That's my personal point of view. It's a very cynical point of view, but I think already the evidence is very, very strong. There's no way in which they could go to, on this JUICE mission, that they would go to the moons of Jupiter and find that there is no life there. Maybe I should really also tell you my interaction with the great sort of 20th century science fiction writer and futurist, a man called Arthur C. Clarke. I knew him personally because he lived for his large part of his life in Sri Lanka. I met him on many occasions. And he was the guy who wrote 2001, The Space Odyssey, a very famous movie was made of it. And 2 or 3 years before he died, he wrote a book in which he made a forecast of future developments in space science and in science generally. And it's the book that I have here now, and I think I wanted just to tell you a statement that he made there, that this is the book, right? Can you see it there? Arthur C. Clarke, Greetings, Carbon-Based Bipeds. And in it, year by year, he forecasts what's going to happen in the future, and he says that in 2061, right, 2061, the return of Halley's Comet, first landing on a comet by humans, the sensational discovery of both dormant and active life forms vindicates Hoyle and Wickramasinghe's century-old theory that life is omnipresent throughout the universe. Right, so this is Arthur C. Clarke writing one of his last books, in which he makes his forecast, amongst lots of other things, and includes AI, the dominance of AI, and so on, which we have heard a lot in recent weeks and months. So I think the evidence is there. The evidence already from comets is very, very strong for life being in comets, and I think I've written about it. I've written all of these sort of huge volume of books on this, right? Something like 30 or 40 books and sort of 400 odd papers and so on. And it is not being taken seriously, because if it is taken seriously, then the game is up for all of these guys who are continuing to search for life. They want to continue to search for life because it gives people a job, it gives people a career, and it generates a lot of money. And so that's my cynical conclusion, that the evidence is all there, and it will sooner or later have to be admitted. The truth eventually prevails. That's my philosophy. So that was the point of view, the Aristotelian point of view, that prevailed over the panspermia point of view, and prevailed for a good 2,000 years. So our revival of panspermia in the 20th century was a shock to many, many people. And certainly all of the academies in the world looked at it in a very, very cynical way, because the academies like the French Academy, the Royal Society, and so on were created during the Enlightenment to promote what they regarded as being true science. And so panspermia had been rejected by Aristotle, so they didn't want it essentially to be reinstated. And so I think there's been an institutional bias that has prevailed against panspermia, and the growing evidence for it is causing a lot of problems for a lot of people. If not for panspermia, we would not be here. We would not be talking on the television in this way. And there would be no life anywhere in the universe. So I think, and even if you're thinking of looking for aliens, searching for aliens and UFOs and so on, forget about it. If there's no panspermia, there's no spontaneous generation of life, there's no life anywhere. So we need panspermia. We need the components of life, the information of life, to be distributed everywhere in the universe and to become assembled in various forms depending on the conditions that prevail in those different places.
This is the continuing series of Blue Planet Red, an award-winning documentary film on the history, evidence for life, and catastrophes that contributed to the death of Mars. The documentary includes interviews with NASA's lead astrobiologist, university professors, aerospace industry scientists, and independent researchers. If Mars was like Earth in the distant past, could there still be life there now? What happened to it? And what turned a blue planet red?